All right, welcome everyone to our Virtual RobotX Kickoff. We are so excited to be hosting another VRX competition this year, partnering with our friends at Naval Postgraduate School and Open Robotics to bring you another competition. So today we're going to cover everything you need to know to get welcome everyone started to our Virtual RobotX Kickoff. All right, I had that playing in the background, so I'm going to turn that off. So I wanted to just go ahead and introduce Michael McCarran and Carlos Aguaros, who are going to talk over everything with you. And as you have questions, please feel free to put them in the chat and we will cover them as we go through today's session. So welcome everyone, and Michael, take it away.
Okay, thanks, Juliana. I'm Michael McCarran from the Computer Science Department at the Naval Postgraduate School. I'm one of the developers for the VRX environment. I joined back in 2018, and I've been lead on the project from the MPS side for the last couple of years. So that's me. And then Carlos, you want to say hi?
Hello, everybody. This is Carlos Agüero from Open Robotics. And like Michael said, I joined the project since its inception in 2015. And yeah, leading it from the Open Robotics side. So excited to talk about this year's challenge.
Awesome. Okay, so the general overview, right? The presentation today is going to be divided into two main parts. The first part is like our good old-fashioned introduction to VRX. If you're new to VRX, or maybe you're just considering participating, this part is probably going to be especially helpful to you. And then the second part, we'll have some slightly more technical notes about how we're running the competition. So hopefully these things will be useful to everyone, but I think they'll probably be especially of interest to people who are already pretty committed to entering VRX 2023. So the first part is going to be our main focus, and I think the second part will be a little bit shorter. The plan is we're going to start with this a quick explanation of why we recommend simulation in general, and then also like why competitions can be useful in general, why they're interesting to do, right? And then after that, I'll talk about what the VRX simulation environment is, why we built it, and why we're having the VRX virtual competition, right? So if you've been participating for multiple years, you may have heard a lot of this already. Sorry if that's the case. I think it will go pretty quickly. And the reason for this is we really want to make sure we're welcoming the newcomers in too, and not assuming any prior experience. We want everybody to be on the same page. After this kind of general overview of VRX, the next thing I think we'll probably spend the most time on is to talk about the list of competition tasks that we're planning for VRX 2023. Many of these are things that we've used in the past, but you'll see we have some changes and some new tasks that we're going to go through. And then finally, at the end of this first part, hopefully you'll be eager to start testing stuff out. So we'll point you towards some resources for getting code and getting involved in all that. Okay, so that's the first part, right? That's the introduction to VRX over here. And then the second part, we really just want to take a little time to talk about two things that we think are going to be of interest to anyone who is competing, right? The first is we've recently migrated the whole environment over to Gazebo Sim and ROS 2. So we want to say a little bit about what that means for you as competitors, especially if you have been involved in past years, right? And then the second thing we want to touch on briefly is our submission process, right? Like how you actually submit your entries to the competition, because like unlike the physical competition, you can't just bring your system and drop it in the water, right? We need a way to get your solution off your computers and to us in a form where we can do something with it. And the reason we're including this is that, unfortunately, despite our efforts, right, the submission process still requires some work on your part, right, on the part of the competitors. And we don't want you to be surprised about it on the day of the submission deadline. And this does happen. So we're trying to draw attention to this, as early as we can, just to make sure it doesn't catch anybody off guard, right? So then finally, my hope is that, at the very end, we'll have time to take some questions and maybe get a little feedback from the group on the new things we're thinking about this year. Okay, so that's the plan for the whole presentation. I'm going to turn it over to Carlos, and we'll get started, on our intro to VRX.
Thank you, Michael. Yeah, let's start with the first part, and we'd like to start with some questions before entering into the meat of what is VRX, and just to motivate why we are doing this. And the first one is, why are we actually creating a competition based on a simulation? So we're going to show you just a few examples of what happens in the real world with real robots. And you can see here examples of a competition in 2015 called the DARPA Robotics Challenge. And most of these robots are around like $1 million. And you can see what happens every time, very often, every time that they try to do something a little bit complicated. Like they like to roll over the floor a lot. So robots are very expensive, are fragile, and this is unfortunately a very common situation. Could you go to the next one, Michael? Thank you. Another example of a real world competition where real world robots are involved. You can see here, this is a team participating in a competition called RoboCup, where these robots, these little humanoid robots need to play soccer. So you can see here the size of a team. It's probably like 20 people around there. And so some people need to do calibration. Some other people need to be in charge of the robots, of the batteries. Some other people need to be tweaking the code. Other people are controlling different aspects of the game. So it's a very, very expensive game in terms of the number of people. Go to the next one, Michael. Here are also a few questions, a few comments that maybe you have heard before every time that you are doing some kind of experiment with your robot in your lab or in the field. Maybe you have heard something like, it seems to be working. So we're not 100% sure, but it seems to be looking correct. It's not working right now, but I saw it working one time. Like I thought it happened one time, or it's stuck. So you don't know what's going on, but it's kind of frozen. This big question mark around everybody, like, I don't know what's going on, or what is it doing? Like these questions are very common, right? When you have real robots, and they are hard to answer because you need a lot of tools to introspect what's going on. And typically, robots are complex. They have many, many pieces, many different components, and many things can go wrong, unfortunately. Could you go to the next one, Michael? So why do we use simulations then? Well, first of all, because computers are cheaper compared with typically like a robot, and they don't break as often. So they are like solid pieces of hardware, typically. Also, like in comparison with all these examples that we talked before, right? Computers can be operated by a single person. You can have multiple computers in a team, and typically you can't afford so many robots in a single team. Also, the simulation in general, it's the tool that lets you control the environment. So you can, for example, isolate individual blocks of software. You can say, okay, for now, I don't want to tackle the perception at all. So I'm going to introspect the simulation to give me like the exact position of all the objects. And then you can continue with your testing your code, isolating that part, right, with perfect perception as an example. And then when all the pieces are typically working, maybe then you enable your perception. It's a tool also that lets you reproduce experiments. So imagine that, I don't know, you observed something fishy when you were testing. So you can go to your computer and try to prepare an experiment. You can try to load a world with the right setup, with the right configuration to reproduce the situation that was not behaving properly. And then you can debug what's going on until you find the solution. It can also let you modulate the complexity, which is the real problem, right, in general in software. So you can start simple, like in the same spirit as VRX. We can propose different worlds, and each world has different levels of complexity. When you can tackle the easier worlds, you can move on to the more complex ones. And always, as always, we say simulation we think it's a great tool, but it's a great tool probably that you use it always in combination with real world testing. So this shouldn't be a tool that replaces real world testing. It's a complement. Just to illustrate this, and not giving you the impression that I'm making this up, like big companies like Waymo, for example, published some data in 2019. So with their autonomous car, they use simulation, and they have driven 10 billion autonomous miles in simulation, just to give you a sense of how, I guess, useful they think it is. Go to the next one, Michael. Okay, so hopefully I convinced you that why we are creating a competition based on simulation. So, but then the second part is, okay, why are we doing a competition? And I'd say that it's essentially fun, or it has to be fun, and it's very motivational. So when you're doing something that's interesting, that's something that where you're having fun, something where you're in a group with other people sharing the same interest, you learn without even paying attention, right? And so that's why we like it. And you can see here, same competition as I mentioned before. This is RoboCup. Go to the next one, Michael. And I think this is another example of a competition called the DARPA Subterranean Challenge. This is a competition that happened in 2021, organized by DARPA. We were involved. What you see here is the same simulator that we use in VRX, Gazebo, and another example. So you can see here, the environment is very different. The environment, it's caves, mines, tunnels, and things like that. And then every team had the opportunity to deploy different robots, like a multi-robot team. These robots could be wheel robots or drones or any kind of robot that you could imagine. And then you need to go and traverse those tunnels and discover different objects and report them and use communication. So the usual thing where you have to exercise the perception, self-localization, behaviors, and many of the usual components in robotics. So very fun competition, and yeah, very challenging, I guess, for the teams. To the next one, Michael. We're going to be switching back and forth. So Michael, I think this is yours.
Yeah, thanks, Carlos. So that's kind of the general overview of like why we like simulations, why we think competitions are good. And now this sort of brings us to Virtual RobotX, right? So the VRX is this effort that we have to bring the advantages of simulations and competitions to the maritime surface vehicle world, right? The VRX simulation environment, like in general, is this gazebo-based simulation for USVs. And we created it in the hopes they would help accelerate the development of autonomy, right? In particular, we were thinking about this situation that we were seeing at the RobotX competition, right? This physical surface vehicle competition, in which the team had typically teams had some hardware people who were building the platform and software people who were working on the autonomy. And a lot of times the software people seem to be spending a lot of time waiting for the hardware to be ready before they could go out and like test their stuff, right? So we thought it would be useful to produce this simulation to help people, the software people stay busy, right? And give them a little time to get started earlier, right? And so as part of the plan to get teams interested, we decided we would host this virtual competition on the off years between the physical RobotX competitions. Right? And this is what we're calling the VRX competition, as distinct from just the VRX simulation environment, which we hope is kind of a general purpose surface vehicle simulation. Right? So that's why for the VRX competition, we try to create environments that mimic the physical arena and are related to or inspired by the tasks you see at RobotX. Right? That's why you can see in the background here, this is an overview of the park at Sydney. And so that's just generally kind of the origin story, right? The broadest introduction for VRX. And it maybe gives you some idea what to expect, but until you actually see what you're asking you to do, what challenge you solve, right? You probably don't have a super detailed view. So the way the competition is set up is we make a bunch of different discrete tasks available for you to try to solve, right? And the more you solve, kind of the better you do, right? This is the idea. And much like RobotX, many of these repeat from year to year, but we also make changes and improvements, and we try to add some new tasks each year to keep things interesting or to match with like objectives that we're kind of hoping people will work on, right? So I want to give you the overall task list for 2023, right? And just kind of do a big review of this. These are the tasks we put together for this upcoming competition in this fall, right? The ones in bold are either new or involve like some kind of major modification from previous years. So what we're going to do is just run through this list at a high level, and then we'll go through and show you examples of each of the tasks, and we have some video that you can take a look at, right? So the first three foundational tasks, right, you can see it's divided into basic and integrated tasks, right? Basic is like we're working on sort of one skill at a time, like one foundational capability at a time, and integrated just means we're going to put them together, right? The first three of these foundational tasks we have done every year so far. These are station keeping, wayfinding, and the perception task. And we're keeping these the same for consistency and because we think they're still useful to people. And then we're adding two new tasks that focus on acoustic perception, right? One of them is in the basic category here, and one is in the integrated tasks category. So we'll talk about them in a minute, right? And then last, we've kept our wildlife encounter task and the scan, dock, and deliver tasks from previous years, but we're changing the way that they are run a little bit. And we brought back a navigation channel, or follow the task path task, which we had the first time we ran the competition, and we replaced it with Gymkhana, and now we're kind of bringing it back to look at it. So that's kind of the overview, and I'll go through each of these things, and you'll have like a kind of a concrete picture of it, and we'll talk about kind of the details of each. I'll do the first for the basic tasks, and I'll switch over to Carlos to talk about the integrated tasks in a minute. Okay. Just a kind of a highlight of our, the new tasks and the major modifications, right? I'll point these out as we go through, right? But again, the basic acoustic task and an acoustic wayfinding task, or an acoustic tracking task, right? And then we're modifying the Gymkhana by replacing it really with a navigation channel. And we're going to try to also make the wildlife encounter a little more challenging and encourage you to use your perception in addition to just kind of receiving ground truth information about where the wildlife is, right? So we're trying to do a middle ground there, but Carlos will explain this. All right. So the actual tasks, right? Starting with number one, this is station keeping. And the point of this task is just to demonstrate that your system can localize itself by fusing sensor data and then can maintain a position and a heading despite potential waves and wind, right? And so to practice this, your WAM-V is spawned somewhere slightly random, and we publish a topic that gives you a goal pose that's relatively close by, and you just drive to the goal and you stay there, right? In the video here, you can see my effort to do this teleoperating with a gamepad. It's not going super great, but the team with the lowest mean error distance at the end of the task is the winner. So if you get to the goal and you hold it, you're going to have the lowest mean score. So that's the best you can do, right? This is, as I said, a task we do every year. And I think it's a good demonstration of the advantages of virtual competition, because it allows us to isolate this core capability that you can build on to create a solid solution to other more complicated tasks. And it's something that, like, in a physical competition would be sort of tricky to judge, but in simulation we can just measure your actual position and the ground truth, and we can have a pretty simple way of evaluating whether you're doing it or not. That's the first task, station keeping.
Can I interrupt you for a second, Michael? Just maybe just a minor comment, but just in case you're wondering, like, these white markers that you can see on the screen are not actually perceived by the robot, by the 1B. So these are just visual aids that we enable for us to know exactly where that be the target position, but they cannot see that, the robots.
Right, that's a good point. Yeah, and we have a bunch of these that I should all of these things that look like this are going to be invisible to the actual system. They're just debugging tools, right? And also without them, the video is confusing, right? So that's another reason that we have them in here. But yeah, that's a good point. Your system will not be able to use those in any way. Okay, so the wayfinding task, right? This this in some ways is just an extension of the station keeping task to include multiple goal states, right? These are published to a topic, right? Just like in the station keeping task. And the objective is for your system to demonstrate the ability to achieve the position and heading values for each of the points given, right? In this case, the way we score you is just slightly different. We record the minimum error distance you achieve for each waypoint, and then we average these together over all the waypoints. So it's like an average of your best result for each of the waypoints as you go through. And so, it's obviously it's very similar to station keeping in many respects, but it does actually involve like a few additional decisions, like what order you visit the points in. That's up to you, right? And also how much time you spend trying to get into exactly the right position before you head off to another point, right? You want to get the best score, but you don't want to time out, right? And there is a time limit for the whole scenario, right? All right, so that's wayfinding. Again, these first two are pretty simple. And then in the next task, we take this break from navigation and control for a bit to just focus exclusively on perception. And in this task, your WAM-V is actually locked in place except for heave, pitch, and roll. So it can move up and down on the Z-axis, and it can kind of rock to give you this the additional challenge of having to make your perception work while your camera is moving, right? And what happens is objects, as you can see here, just get teleported into your field of view, right? So it's super artificial, but kind of useful, right? The goal, is to identify which objects you're looking at and say where they are, right? And the scoring for this one's a little complicated, but basically your score is the average of your localization errors for all of the objects you correctly identify, and the low score wins, right? So you say where each one is, and we figure out how close you were, and the closer you were, the better, right? If you misidentify objects, like you say it's a red buoy when it's a green one, or you forget to, or you don't mention them at all, then you get like a maximum error of 10 meters, like it's a penalty added, and if you identify them correctly, but your coordinates are like way off, we cap your error at 2 meters. So it's not like you've blown up the whole thing by, picking something too far away. But anyway, that's generally how it works. And the idea is just to practice finding objects and saying where they are. All right, the last of the basic tasks here is acoustic perception. And this is the first one that's new for this year that I'm talking about. So we wanted to give a little more attention to acoustic perception in general, right? And the hope is that we're paving the way for a future in which teams might be required to communicate with an underwater vehicle, right? Or something that's transmitting a little bit more, right? So in the spirit of our basic tasks, right, we've kept this as simple as possible. The WAM-V will be spawned somewhere, and the acoustic beacon will appear somewhere underwater, and the beacon will broadcast its location relative to the WAM-V by publishing a range, bearing, and elevation. We add a little noise for realism, right? And then the goal is just to get as close to it as possible as fast as you can, right? So once you're within a meter of the projection of the vertical projection of the beacon to the surface, the run ends, right? You've completed the task. And the score is just the amount of time it took to finish. One thing I should say is we reuse this visualization marker here from the wayfinding, but it's not really that. You should ignore that heading, right? Because this does not have, you don't have to be in a particular heading, you just have to get to the spot, right? So sorry about that artifact, just want to mention that in case it's confusing anybody, right? So again, here you try to get to these things the fastest. I've shown kind of an example of the output or something like what it will look like. And the lowest score wins, right? All right, so that's it for the basic tasks. And then I'm going to switch over to Carlos. He's going to tell you about the integrated tasks.
All right, so I'd like to, maybe before entering into, could you pause the video for a second, Michael? Maybe before starting with the task, I'd like to clarify two things. The first one is that, not clarify, maybe explain it, because we didn't have the chance to talk about this. So typically the way the competition works is that every team needs to propose one single solution, and that solution needs to fully autonomously solve all these tasks that we are presenting here. Maybe it's kind of implicit, but it's important to clarify that there's no human intervention at all in all these solutions. Then also we are going to modulate the complexity of these tasks in a way where we are proposing, for example, all the tasks that we are describing here. And then for each task, we're going to run or we're going to execute your solution multiple times. Let's say, for example, 3 runs per task. And then we're going to change some configuration of the environment in each of these runs in a way that the environmental conditions are gonna be more complicated, more challenging. And that means like maybe the waves are gonna be a little bit more rough, or the wind is gonna be blowing stronger. So you're gonna have all these external factors that are gonna make your life a little bit more difficult. But we're gonna do that progressively. So, and that's a way also to change the conditions a little bit. So then now we're entering into this integrated list of tasks where you're going to see that it requires to have multiple components in order to solve them. So typically some kind of perception combined with some kind of control, because you need to keep adjusting your robot based on some kind of object that's moving or some kind of sensor that's giving you the right coordinates. So the wildlife encounter, the goal is that there are 3 different animals floating on the water. There's a crocodile, there's a platypus, and there's a turtle. And the goal is that you need to do certain behavior for each of the animals. What you can see here, it's a platypus. So you need to approach the platypus and circumnavigate around the animal clockwise. And obviously without hitting the animal. You need to respect the animal. So anytime, if for some reason you hit it, then your circumnavigation algorithm is going to reset it. So you need to keep doing it. The turtle, it's similar, but counterclockwise. And then the crocodile, what you need to do is avoid it. So you need to stay always away. You need to keep a certain distance from it. So that's the wildlife encounter. Then you're gonna get points based on how well you do these behaviors. Then if we move to the next one, that's number 6, is follow the path. So then what we have created here is a course where there are different buoys. Typically, a buoy is a gate is a pair of buoys. Always has the red color on the right and typically the green on the left. But the first one is a little bit special because it's white and red. And the last one is also special because it's black and red. You can see also that there are these black round buoys around, which are obstacles. So in general, everything is an obstacle. You shouldn't hit any buoys, but the black buoys are usually placed more in the trajectory of the gates. So your goal is to identify all these buoys, try to match them into where you think it's a gate, cross those gates, or cross as much as much gates as you can, and also in the right order as much as possible, and without hitting any obstacles. And as I said before, one of the challenges is going to be the wind or the waves, and sometimes we can also change the background, and then the color of the objects are not going to be so crisp. So there are a few things that we can tweak. Can we go to the next one, Michael? Task number 7. So as Michael mentioned, we're going to see acoustic. Could you pause the video for a second here? I wanted to explain a few things here. So what the 1B can perceive here is just the water and black buoys, which are obstacles. Now for this video and just for debugging a little bit, or just to explain what's going on in this video a little bit easier, there's an acoustic pinger under the water that in this case is moving. So that's one of the tricky parts. It's moving out there in a trajectory that you don't know in advance. The goal is to stay as close as possible, obviously at the surface, to the pinger. So the closer you can track that movement, the more points you'll get. But it's gonna become tricky because sometimes you're gonna try to trade. Okay, I want to be closer, but I don't want to hit these black buoys. So it's up to you to decide, how to handle those kind of situations. as I said, for the video, the finger is represented as with this. You can enable it now, Michael. It's represented with this white box in the around the center, but you're not gonna see that. So what you'll get is your acoustic sensor will get a range and 2 angles to the finger. And only for the video, I also enable these orange buoys, which are the targets of the, I guess, the waypoints that the finger is following. In other words, so you're not gonna see those, but it's just it's helping us just to see where the finger is going. So essentially, that's the goal: using your acoustic sensor to track the position of this finger and follow it as much as possible without hitting any obstacles. Go to the next one. This is the last one. It's called Scan, Dock, and Deliver. It's a multi-part task where the first thing to do is approach to that special buoy that you can see right now on the screen. It's called the light buoy. And it's displaying a 3-color sequence. And then based on that sequence, it's going to, well, you will need after that, you will need to recognize that color sequence, first of all. And then after that, you will need to detect this dock and approach it. And you see that there are different figures with different colors, like a yellow circle, a blue triangle, and a red rectangle. So the color sequence is going to dictate which bay is the right one to dock. So in this case, the 1B is deciding to dock in this second bay. And then that's part of the task. So making sure that you know how to do that, that you can approach this bay and then stay as much close as you can to the end part of the bay. Then there are a few holes in this white placard. Hopefully you'll see them later. Now they are starting to appear. And then there's a ball shooter also installed in the 1B. So part of this task it's also try to throw a ball into one of those 2 holes. So you need to, aim for those, and you see that I'm starting to. There's a blue ball here, and I tried to shoot a few of them. I was not very lucky, and then you need to also leave the bay. So as you can see, many things to do, and that's why it's one of the most complicated ones, especially when you consider wind, waves, and many of the environmental factors. All right, Michael.
Okay, thanks, Carlos. Before I move on, I want to make a quick note about the wildlife, because I added a detail when I was introducing it, which I said we wanted to move toward encouraging the use of perception for that task. And so I want to say what I mean by that a little bit, right? That the first year we presented the wildlife encounter was the last time we ran this. The first year it was in Sydney, right? And it was related to a robotics task that had been introduced. And when it was the first year, we tried to make it as simple as possible. So we just published topics that said exactly where the animals are, right? And which animals they are. And we're still doing that. We're not like totally pulling the rug out from under you here, but we're going to slow down the publication rate of those messages. So on some of the easier runs, maybe you'll get them once a second, but on the harder runs, it'll slow down and maybe once every 10 seconds, right? So this will mean teams that are looking, using perception to try to find the location of the animals will have an advantage in completing the task, right? And so we'll see how this goes, and like maybe we'll kind of year to year as we progress, we may add more and more challenges to this. All right.
Thank you. Yeah, that's a very important point of the task that I forgot. And you can see we are kind of going through an hybrid approach where perception is not strictly needed, but if you start incorporating perception into this task, we believe it's going to help you a lot.
Yeah, awesome. Okay, so hopefully that's gotten, if you're watching and wondering what it's about, you're now at the point of like, I want to go and check it out, right? So that's what this slide is for. Just a bunch of links, right? So if you want to download the code, install it, get it running, right, go to our GitHub page. There's also a wiki there. That in the normal place for GitHub pages, you just click on the link and look for wiki. That has some tutorials, right? It gives you the installation instructions, etc. We also, in the past, we've used a forum for communicating with teams and like competition related questions. This year, that's getting updated to a Discord, which RoboNation has kindly set up for us. So that's the link there to join the Discord. Everybody is welcome to do that, encouraged to do that. And then finally, our 2023 website for VRX 2023 is now live, and that's also at robotix.org. And you can go there, and that's like a nice kind of central location to find everything, right? It has links to the documentation, links to the GitHub page, and the schedule, and all these things, right? So that's how to get started. And I want to say also, a little bit about the timeline, how this is, we plan this. You could, very basic timeline here. So like 4 points, right? But the first thing coming up is June. We're going to try to get our final code release out by June, and hopefully this will have you can actually try out all the new tasks now, but hopefully we will have implemented everything we're planning to implement for VRX 2023 by the June release, right? And the documentation will be stable. Right now we have released preliminary documentation. We're going to have to make a few updates over the next couple of weeks, but then it will be finished, right? And then registration will open, and I think we have planned. Juliana will talk about this at the end, but I think the date is June 5th for that. Okay, so that's the near term, like the next kind of near term event, right? Then the actual competition will start in the fall, and the first part of this we divided into 3 phases. In the interest of kind of getting people involved early, and also like sort of getting you to sort of pace your development a little bit, right? So the first phase is our Hello World phase. If you've done this before, all this is you get the simulation running somewhere, and you make a video of it, and then you submit the video, right? And we have sometimes, teams get really excited about this, and they have like these sort of cinematic, epic videos showing them demonstrating all the tasks. That's awesome, and we appreciate it. But sometimes it's like, well, here it is, it's running, right? And that also is fine, right? So we want, this is just a proof that you looked at it, right? So we don't wait until the very end to actually get it running, right? Then October will be phase 2, and this is what we call our dress rehearsal phase, right? It's actually like almost identical to the final competition, except we have, we will change the worlds a little bit that you're going to try on the final competition, so it's not exactly the same tasks. But all of it, basically, this is you submit a full solution to as many tasks as you want to tackle, and you take your submission and run it, and we score it. And we say what the competition, what the results would be if this had been the finals, right? Now, anybody who submits anything moves on to the next round, right? So you are not required there's no like getting knocked out for not completing enough tasks, right? Obviously, though, the more you do early, you sort of the better position you are in general, right? But this is a nice place to kind of work out the bugs, make sure your solution is getting submitted, it's working the way you're expecting, right? And that if there's any discrepancies between what you're seeing on your system and what you're seeing on our system, hopefully we pick this up at this phase, right? And then December is going to be that's when we have our phase 3, which is the finals, right? And if essentially this is the one that counts, right? It's you go through all of the tasks that you have submitted, or that your solution will work on, right? And we score you, and then the outcome of the competition is based on how you do. This is like the real. It's based on how you do on the finals, right? So we don't carry anything over from the previous phases. We do sometimes at the end acknowledge people who did things that didn't show up in the final scoring, like they made a cool video or they did something interesting in other places. But generally, for the final ranking, the finals is the sole determiner of how you do. All right, so that's the timeline, and that also completes our part 1, this introduction to VRX. And so what we're gonna, Carlos, maybe you have anything you want to add before we move over? Oh no, you're just getting ready. Okay, so if there's nothing anyone's adding, it's time to move over, and we're gonna start part 2, which will contain some of these like technical notes that I think, as I said, will be, I think of interest to everybody. You want to see them early, but like you'll maybe be kind of they'll be especially helpful to you if you are committed to running to being part of the competition this year. Okay, Carlos, take it away.
Thank you. So the first topic we'd like to talk about is an important change that we did this year compared with the simulator used in the previous editions. So before we were using what it's called right now Gazebo Classic, and now we are going to be using Gazebo Sim, which is the newer generation of the Gazebo simulator. The reason for doing that, it's multiple. One is because it's currently the simulator that we actively maintain and then we actively develop. So we thought it was worth it to make this migration for the long run. And we know Gazebo Classic is going to be deprecated in just a few years, so it's worth to do that migration as soon as possible. But it also comes with some advantages. There's one visual advantage that's very good. So it's using Augur 2 instead of Augur 1, and that brings us something called physically based rendering, which you can see here on the screen how the dock looks without PBR and with PBR. So you can see that with PBR it gives you more texture and maybe like a feeling of a better feeling of how the material it is of the dock. In this case, it's more like a plastic or rubbery material. So I think it's a little bit more realistic in that way. The new Gazebo simulator has a lot of changes internally. So that's not something that should affect the end users or the participants here, but just out of curiosity, we are using something called the entity component system, brought from the game community, which we think is going to benefit how in general Gazebo works. It has a way more modular design. So right now, for those who are familiar, Gazebo used to be like a monolithic project with a very big code base with all the pieces in a single repository. Right now, it's a different approach. Right now, it's a collection of many different components that are living in different repositories. So we think it's a better design. And then typically what we expose as the API to access the actuators like the thruster and the sensors is the well-known ROS API. In the past, we were using ROS 1, and we took also this opportunity to migrate from ROS 1 to ROS 2 for the same reasons. And this is something that it's going to affect you if you were using ROS 1 before. So now you have two possibilities. You could migrate your code to use ROS 2, or you could use a bridge. So you would have to bridge ROS 1, ROS 2, which there's already an existing bridge. You don't have to do it, but just so you know. I'd like to clarify also this aspect. What we are exposing is a very, very, very thin API, just to access a few topics for consuming all this information, the relevant information that you need. That doesn't mean that the way you program your code and your robots needs to be ROS. No, not at all. The ROS is strictly needed for accessing that API, but then once you consume that, you're free to do whatever you like. You can use ROS in Python, you can use ROS in C++, or you can use any other approach that you want or any other middleware that you want. As the only, I guess, thing that we're forcing you is to consume that via ROS 2. That's the only thing. Having said that, can we move on to the next one, which is related with the submission process. So along this competition, you're gonna be understanding first of all what the challenges that we are proposing you. Then you typically start writing your solution. tackling maybe the basic tasks, then the integrated tasks, then maybe the more challenging environmental conditions, etc. And then at some point, the final competition will approach, and there's a point where we will ask you to submit your solution. We need to do that because we need to test your solution, and then we need to score it. And then this is a real challenge for us. So we want to clarify a little bit how we do it, and also what we noticed in the past. And one thing we noticed is that the competition itself presents some challenges, which we already hopefully presented to you, but the submission itself might also be a little bit challenging for those who are not familiar with certain technologies that we want to mention here. So we want to highlight that the submission process is not trivial, especially if you're new to this technology. So hopefully we'll highlight this enough for you to pay attention to it as soon as possible and try to learn a little bit about it, and make that process a little bit smoother. So what are the main two technologies that you need to know about that are going to be very relevant in the submission process? The first one is called Git. So it's a version control system. It's going to help you writing code when you have a team of people doing that. And then at the same time, we're going to use Docker Hub, which is like this very well-known product owned by Microsoft these days, that it's like a web application that under the hood uses Git and offers you the ability to create code repositories and interact with them via web and also via command line and other ways. So that's a very important tool that we're going to use. This is what we use to host our project and to have a list of issues. And we do at the regular development using Git and GitHub. There's going to be a second tool called Docker. And for those who don't know this, it's like a lightweight virtual machine that it's going to use like the hardware that you have on your host operating system. And the idea of Docker is that lets you create like a binary blob of your code in a way that it's kind of isolated from the rest of your computer. So we don't have to know anything about how you create your solution, but we're going to have you will have a way to share it with us. So I'll go into a little bit more detail right now. But in any case, it's a good time to get familiar with those two tools in case you're not. And because in any way, we think that it's going to be very useful for you in the future. Those are tools that are, at least right now, are very, very useful and very, very used in general, as in the software development. So can we move to the next one, Michael? So what is Git doing? I'm going to try to give you just an example of this. So when you have multiple people trying to write a code, which is usually what's going to happen here, what happens in many projects, you need some tool to help you do that. So Git, it's there to help you when multiple people are touching the same code base, and there's going to be conflicts, and there's going to be a process for each person to contribute a piece of code to the project. So there's so many commands and so many tools out there, but Git is right now it's one of the most common ones. So why are we using Git for the submission process? Well, this is because we created a particular repository called VRX events, and with a relatively simple structure. And that structure, it's a collection of folders and files. So there's a top-level folder with a year. This is the year of the competition. Then if you go inside 2023, for example, there's going to be different competitions for those years. For example, VRX phase 1, VRX phase 2, VRX phase 3. If you go into one of those subfolders, for example, VRX phase 1, what we want to have at the end is different subdirectories, and each subdirectory with the name of, we want to have that subdirectory with the name of each team. So that's the part that you want to contribute to that repository. So we want to create what is called a pull request. So we want you to push some changes to that repository with a directory containing your team name, and inside some files that are going to be needed for your solution. This is essentially what we want, and Git and GitHub is going to help us in general, you and us, to do that process. And then why Docker? So what we want to do is isolate so many of the differences in the solutions and in general, like the competitor system. So one team might decide, oh, I want to use, I don't know, these dependencies for using Python and using all these libraries, but other competitor wants to use maybe CUDA, and a totally different approach. So how do we test all of that? How do we install so many variety of dependencies, etc.? So I think Docker is there, comes to the rescue, because you as a team is going to create what is called a Docker image, and then you will actually, install all the dependencies there. You will do whatever you want inside that Docker container, and you will push it to what is called like a registry. So for example, Docker Hub. And then when it's there, we will be able to download it and maybe start it. So we don't need to look inside. We don't need to know any of the details, but there will be some convention, and we will have a way to start your solution that's running inside that Docker container. So that's a way for us to have like a common or uniform interface and run all the team's code in the same way. Can we go to the next one, Michael? Okay. So maybe summarizing everything and at a very high level. So what you have to do to submit a solution is, first of all, you need to create that Docker image. And so you need to, we're not gonna describe right now how to do it, but you will need to learn how to do that. We will try to have a tutorial also, but this is a technology that's very wide and deep. So maybe there are certain aspects that are not captured in the tutorial. So when you have created that Docker image with your solution, you will push it to Docker Hub or any other registry. So at that point, it's living there in the cloud. So then when you have that, that's the first half. Then the second half is that you will need to go to VRX events repository and create a pull request. So your pull request will need to create, we need to contribute to the code.vrx events with what we described before. So you need to create a directory with your team. Inside that, you need to create the right files. If we're talking, for example, about phase one, typically it's just a single file with just one line inside, which is the URL to the video. If we're talking about phase two or phase three, maybe it's a little bit more advanced because you need to create 3 different files. One will have the URL to your Docker Hub. That's how we can get your Docker image. And potentially the other 2 files will have your configuration for the 1B. One is going to be the thruster configuration, and the other one is going to be your sensor configuration, because you'll know about this later, but you'll have the ability to tweak how your 1B looks like. And then when you have that, you'll create what is called a pull request. So you are requesting that piece of code is going to be merged into the VRX event repo. We'll look into that. We'll approve it. We'll merge it. And then we'll do that for all the teams. That's how all the submissions are going to work. That's it from me, Michael.
Yeah, great. Thank you. So I just want to say a few things about the submission process. I know this part of the process is sometimes people are less familiar with these tools, GitHub and Docker, right? And in case it seems like, if you're new to them at all and it seems like a lot, right? I want to say, we generally try to be available, Carlos and I and some other people who work on the project, to help teams troubleshoot submissions and make sure that we are able to run your system the way you're able to run it. And in the past, we've been pretty successful with this. I think we build in some extra time into the submission process to correct like minor errors, like maybe your submission is in the wrong format or the link is wrong or something. So typically we figure it out eventually, but the earlier kind of you get involved, I think the easier it is for us to give everybody attention, right? Who might need it, right? And I think also, we have been creating tutorials that are getting better. So I wanted to do, we weren't sure how much time we would have, and it looks like, we're kind of getting close to the top of the hour. I want to say one thing that we're thinking of a change that's going to be introduced this year, and then kind of find out if there are anybody who has kind of outstanding questions or things we want to talk about. Since we are close to the end of the hour, I think we can also continue this on Discord. So if you have questions or comments that we don't get to, don't worry. Just join the Discord and post it there, and we'll look for it there. So before switching over, and I see there's already questions coming up, but I just want to say that the one thing that we were thinking of doing this year is, in the past, our phase 1 has just been to produce a video, and we don't make you do anything related to Docker. You do have to use GitHub to submit it, right? And I think what we're going to do this year is have you produce that video, but also have it involve some demonstration that you've used Docker to do something, right? Maybe it may just be like a Docker hello world. And we don't want to create a lot of burden, so that it seems like extra work, but it does seem like if you do it then, that this will kind of get, maybe this is a time when you're not as stressed out about getting your final code in, and so it would be a good time to practice it. So that's an innovation we're going to introduce this year. And if you have kind of ideas or reactions to that, it'd be interesting to hear that kind of before we fully make it part of the documentation. All right. Now, having said that, I see there's a question. Oh, good. And Carlos, you want to take it? Maybe we should read this question.
I can talk about the first question that I see here. Somebody is asking, is the competition more focused on people starting in marine robotics, or also for people with experience? So I'd say that both. One of the advantages of simulation and one of the goals of this competition is to lower the barrier of entry into RobotX, for example. So RobotX, it's not a trivial competition because you need to afford. I know there are helps and different mechanisms to help you with that, but in general, you need to get a 1V, which is not a super cheap robot. But simulation, it's relatively free. So we want to use it as to help new teams joining these competitions. But at the same time, if you are already an experienced team or even a participant in RobotX, that's great. Like you're more than welcome to continue to use it for potentially your development, and also to join the competition, which is going to be, we think it's going to be fun. There's another question here. Maybe Juliana, I'm not sure if you can tackle this one about.
Yes. Yeah, the second question is asking if it's possible to participate as a research institute or just as universities and schools. We do ask that each team is associated with a school, a university, or a club, but we sometimes take that as a case-by-case basis. So if you have a particular scenario, you can reach out to us. We also really recommend that teams are associated with mentors and advisors in industry as well. So you can link up with a group of students and tackle this competition. The team doesn't have to be specifically associated with the school, but we do ask that it's predominantly students that are part of the team.
Yeah, I would say the intent here is like if I don't know who's asking the question, but if it's like a representative from Boeing or like some, yeah, we don't want kind of a massive disparate, a massively disparate sort of competition field. They kind of keep it so that the students can participate in it. I see another question coming in. Oh, Juliana, I think the answer is yes, but Juliana, will you confirm?
Yes, the question is, will the video of this live stream be available to watch later? As soon as we finish the live stream, it will automatically be available to view on YouTube where you're viewing it now. So you'll be able to go back and watch it anytime you need or share it with others.
Okay, should we go to your wrap-up slide, Juliana, and say like further, if you have further comments, especially thoughts about the submission process or what any aspect of it, please join Discord and we'll be active, kind of looking for your comments or questions there.
Absolutely. And we are ending right on time. So thank you, Michael and Carlos. That was perfect. Thank you for covering everything. It was a great summary of everything that teams need to know to get started with VRX, but also just the importance of simulation. So you guys covered wonderful topics, and it's great to hear in the comments that people are going to use this to share with their classes or with their fellow students to continue getting prepared in this arena. So I wanted to give you all next steps, particularly if you're interested in competing in VRX 2023. So if you look at the screen now, we have an intent to compete that is open today. So if you know that you're already interested in competing, please go ahead and fill out that intent to compete. We'll post the link in the chat so you can easily just click that and get started. You can also scan the QR code. But we just ask that you go ahead and sign up so that we can continue sending you more information and you can be in the loop on everything that will come this competition season. And like Michael mentioned as well, if you have questions or if you want to continue discussing with Michael or Carlos or any of us at RoboNation, please go to the RobotX Discord. We'll also post that link in the chat so that you can go ahead and get started connecting with the community, getting ready for the competition and just getting more involved in simulation. So thank you all for joining today. Thank you again, Michael and Carlos. That was wonderful. And we can't wait to continue linking up with you all as we gear down Virtual RobotX again this year.
Thanks, everybody.
Yeah, thanks, Juliana. Thanks, everybody.